So this is the second part of problem solving with gamma function. So we have left with some sort of problem. So it is given that this integral or the this following integral basically converges. So we have asked to evaluate this integral by a suitable substitution. Okay, so for this problem number 1 we can substitute that u equals to minus natural log of x. Okay, and we want, so it is dx equals to minus, so yeah, so dx equals to minus e to the power minus u du. Okay, so since this minus u equals to natural log of x, and we can write this x equals to minus e to the power minus u. Okay, so and the limit will be as x equals to 0. Okay, so for u it will be positive infinity and x equals to 1. So for this u equals to 0, right? So if we write this integral 0 to 1 x natural log of x to the power n dx, so it will, by substituting, it will be written in so wait. So yeah, so minus yeah, okay, so this is positive infinity to 0, so we can write it out e to the power minus u to the power n great, and minus e to the power minus u du. So we can write it in the format of integral 0 to infinity e to the power minus n u and minus u to the power n minus u du. Great. So this minus 1 to the power n will be outside of the integral, so it will be 0 to infinity, so e raised to the power nu, e to the power minus u to the power n du equals to minus 1 to the power n, and this is 0 to up to infinity, and we'll write e to the power minus n plus 1, wait, n plus 1 times u and u to the power n du. Right, now what we can, so again one more substitution we needed, so that is so t equals to n plus 1. Okay, u which is u equals to t times t over n plus n, and the du will be 1 over n plus 1 dt. Great. And the whole things, so this integral, so if I talk about this integral, so this integral will turns into, so let me cut this out. So yeah, so see the next page. So as we have already solved, so this is solved in the problem solving with gamma function 1. So yeah, next page. Yeah, yeah, so yeah, so here we can do this. So let me paste it out. Yes, so yeah, so this integral can be written in this way. Okay, so minus 1 to the power n integral 0 to infinity e to the power minus t over n plus 1 to the power n and 1 over n plus 1 dt. Okay, so we can write this minus 1 to the power n times 1 over n plus 1 which raised to the power n plus 1 as well. Yeah, so this is 0 to infinity and e to the power minus t and t to the power n dt. Now as you all know that, so this will be minus 1 to the power n 1 by n plus 1 plus 1. Okay, so so this integral will be gamma n plus 1. So our final answer is minus 1 to the power n over n plus 1 raised to the power n plus 1 times n factorial. So this is n plus 1 times n factorial. Yeah, so this is the solution of our gamma function, I mean the desired problem. So we were here. So next problem is this. So yeah, so you can pause the video and check this yourself. So So this problem is basically a signature problem. So you know that this gamma of n equals to 0 to infinity and e to the power minus t and t to the power n minus 1 dt, right? So we can adjust these things out a bit, like let uh, so we call it j. Okay, so j equals to 0 to infinity, and this t to the power n minus 1 times e to the power minus half of t natural log of t dt. Okay, so we observe that one things. So we observe that so what we can observe that d dx of t to the power x minus 1, which is t to the power x minus 1 times natural log of t times 1, which is t to the power x minus 1 natural log of t, right? Now so we can write this j equals to 0 to infinity del x of t to the power. Okay, so let me write it in as I was writing it in. So t n minus 1. So okay, so this is n minus 1. I was writing it out. So t to the power n minus 1 times e to the power minus half of t. This is d. Okay, so del x of 0 to infinity t to the power x minus 1 e to the power minus half of t dt, right? So let you can take it u equals to half of t, and we need dt equals to 2 times du, right? And t equals to 2u. Okay, so from this this j can be written as del x 0 to infinity, and this will be 2u n minus 1, sorry, again mistake, n minus 1. Okay, n minus 1 e to the power minus u 2 times du. Okay, so it will be del x of 0 to infinity 2 to the power n 2 to the power n times u to the power n minus 1 e to the power minus u du. Okay, and so this is j, so j equals to del x, 2 to the power x. So okay, let's write it at x. Okay, so that the entire things will be balancing out. So let's denote it as gamma of x. So this is gamma of x, so x minus 1, so x minus 1, okay, and yeah, x minus 1, this is x minus 1, okay, so we were doing this t to the power natural log of, okay, this is natural log of t, yes, yeah, I guess I am correct. uh, so wherever this n is there, so make it x minus 1. Okay, so x minus 1, and so this is x and this is x minus 1. uh yeah, I guess it's almost right process I'm going through. So yeah, 2 to the power x, 0 to infinity, so e to the power minus u times u to the power x minus 1 du, right? So let's write it del x of 2 to the power x gamma of x, right? Now so if I just differentiate it, we'll get this, so it will be 2 to the power x, okay, and this natural log of 2, and this gamma of x plus 2 to the power x gamma of gamma dash. That means I am derivating this gamma function, so gamma dash x, and the whole things turns into things. So let's take it the j1, so that it will help us to evaluate the things. So if we take the j of 1, that means this 2 natural log of 2 gamma of 1, okay, so plus 2 gamma dash 1, okay, so that means 2 natural log of 2, and it will be 2 gamma dash 1, okay. So as you know that gamma 1 is 1, so I am writing this now. this gamma dash x is gamma of x. Okay, and we can write these things. So gamma x, and this is minus. Uh, this will be uh, deriving from a. So you can assume that. Okay, one more thing I have forgot to provide you, that is this here in this problem. So here, so it will be given to you that this, or you can figure it out, this gamma dash x. Okay, so as it is a bit of complicated to figuring out, so maybe while in a simple problem it will be given that this gamma dash x is gamma of x. Okay, and this is minus of this, so this gamma of, so this is small gamma and this capital gamma sign, and 1 over x, and this summation, uh, it will be, I guess, 1 to this whole thing 1 by k, yeah, so it will be k equals to 1 to up to infinity 1 by k minus x plus k. So it will be given. So once cross check yourself while uh, writing these things. Okay, so uh, so here in this, according following up to this problem, so this gamma dash x, so will be given to you. So from that point of view we can write that gamma dash 1 is equals to gamma 1 equals to sorry, this is gamma 1 times minus small gamma minus 1 plus, actually this gamma dash x is maybe I don't have remember right now. So it may be something called the digamma function. So maybe I could be wrong. So once you can check it out by googling or Wikipedia, so you can check it out. So if I am using some misterminology, so you can verify and you can make me correct, and you should do that, and I will be thankful to you guys. So 1 by k, that is 1 on k plus 1. So as x equals to 1, so um, so k plus 1. Okay, so if I just, so this gamma 1 is 1, so minus gamma minus 1. So if we just expand this entire series here, so you can see that this is our telescoping things. So minus 1, so it will be something called plus 1. Okay, so this telescoping, all of the things terms will be cancelling out, and we'll left with gamma dash 1 with minus small gamma. So 2 ln 2 plus 2 minus gamma. So that will be yeah, 2 times minus gamma, I mean. So we'll left with, so the answer will be 0 to infinity e to the power minus half t natural log of t dt equals to 2 times minus gamma of natural log of 2. So this is the answer of this integral. So don't worry, so maybe while dealing with such problem, so sometimes maybe it will be provided to you, or maybe you could be derived. So this derivation little bit tricky, and it is not easy to derive. So maybe in some sort of problems it will be given, or you have to figuring out, but still it is not easy to deriving out. So if we jump to our next problem, so this is the final problem which we'll discuss today. So if I just do this thing, so how you could prove these things out. So you see, so these things can be deriving out some from some very important um, integral concept, that is multivariate things. So uh, so this gamma of half, um, so this is given, okay, so this is given to you and you have to show this. So this part is can be, so if you know the beta functions and some sort beta functions, so I will definitely discuss some beta functions related things, and I have already decided to make these things. Uh, so there is a relationship with gamma functions and beta functions. So what does beta function means, I will definitely discuss in this session. Maybe some sort of definitions and stuffs you know about beta, but still I will definitely discuss to, as I am defining these gamma functions from scratch. So I will definitely derive the gamma functions and I mean the beta function and its consequences from very scratch, and I will try to figuring out overlap, I mean the showing you, I'll be showing you some um, consequences and the relationship which is related to beta and gamma, and the relationship between beta and gamma, and there will be so many problems. So from that things, this formula can be generated using some recurrence things and recurrence formula. So yeah, so but there is another way to deriving out. So as I promised that I'll show you this thing, so you can use um, the concept of multivariable calculus, so that it will be a bit easy to tackle. So as gamma of half, okay, is nothing but equals to 0 to up to infinity t to the power half of minus 1 and e to the power minus t dt. Okay, and 0 to infinity t to the power minus half e to the power minus t dt. So by substituting t equals to so we'll t half t to the power half, so we'll write t to the power half equals to u, and so the dt will be 2u du, right, and the limits will be unchanged in this case. So if we do so, if we follow up this, so we left with 2 times 0 to up to infinity e to the power minus u square du. Now let um, let I equals to 2 times 0 to infinity e to the power minus x square dx, and I equals to 2 times 0 to infinity e to the power minus y square dy. Okay, now if I do the I square here, so you will see this 2 times 0 to infinity e to the power minus x square dx, and 2 times 0 to infinity e to the power minus y square dy, so it will turn into 4 times 0 to infinity, and this will be 0 to infinity e to the power minus x square plus y square dx dy. Now you see, now we'll change our coordinate into polar. So as we are doing it into the Cartesian coordinate, so we'll just change our coordinate into polar. So what will be the what we can do? So x square plus y square equals to r square, we are assuming. So dx dy will be what? R dr d theta. So you can figuring out this thing. So let's take a graph. So this is x, this is y. Okay, and see, so you can see this thing. So this entire things, so we'll change our coordinate. So this is 0 0, so this is 0, so this becomes what? So this is our range of x and y, and so this becomes this. So it will be, so if it is polar coordinate, so the coordinate will be r comma theta. Okay, so 0, so it is close, and this, yeah, this is open. Okay, and this is 0 to theta, and this is pi by 2. So we are taking it r comma theta. So in polar coordinate, you know that. So I square will be 4 times so this is theta equals to 0 to pi by 2, and this is r equals to 0 to infinity. This is e to the power minus r square times r dr d theta. And you see that if you perform the, so this is dr d theta. So those who are aware about the multivariate calculus, so you will see that it will turn into, so this result is nothing but pi. Okay, so I equals to root over pi. Okay, so therefore we can say that gamma of half is nothing but, so gamma of half is nothing but root over pi. Okay, so hence we have proved this. So yeah, we have proved that gamma of half equals to root pi. So this is a very easy way to do so. So again there is another way to do so. If it is given that the integral 0 to infinity modulus of natural log of x, this minus half dx, and so instead of this entire things, suppose this given, and you have to ask that you have to prove this. So how you could you can prove this out? So you can tell me in the comment box, or you can do these things yourself and send it to me in my via my mail. Okay, so yeah, so I'm ending this problem solving session, and we'll come to more problems while after discussing with you the beta functions and the relationship between gamma and beta. So that will be a bit of long session. So for today, okay, goodbye. So we'll see you in the next session. So thank you for your patience. Okay, goodbye.